Hi. So in a previous video, we saw how the HTLC endorsement works and how the infrastructure is laid out. We saw that there is an endorsement field that is kind of like a Boolean. You could set it to 1, which means that you trust the payment, or you could set it to 0, which means that you don't trust the payment. And in this video, we're gonna move to the second part of the proposal, which talks about, like, we did see this example of how the nodes set the endorsement field. In the second part of the proposal, we have a recommended reputation method that talks about how a single node, for example B, can assign reputation to its neighbors, so it would know which of its neighbors it's gonna trust and send the HTLCs as endorsed, or which one of them it doesn't trust and would send the payments as not endorsed. So if we move to the second part of this, in the first part we did see that we basically break our capacity into two parts: an unknown allocation slot, an unknown allocation liquidity, and a part of it that is saved for the endorsed payments. And we also saw how the endorsed field works. In the second part, we have a recommendations for reputation. So we have a recommended reputation system for a node to calculate the reputation for its neighbors. So some of the variables that we're gonna use and we should have in mind is resolution period, which is kind of like an expected time for a payment to fulfill or fail. So for example, if an HTLC comes through, we expect it to either fulfill or fail in under 60 seconds. Otherwise, something is wrong. Otherwise, the HTLC has been in flight for too long, and that's not a good outcome. So the next variable is resolution time. This is the actual time that it takes a HTLC to resolve, either get fulfilled or fail. So what we want, like the good outcome, is for this resolution time to be smaller than the resolution period. So this is we don't want the resolution time to be longer than resolution period. So in the next part, we do have the fees. Fees are basically the fees that the HTLC is paying us as the node. And we do have the opportunity cost, which is calculated as the resolution time, the ceiling of the resolution time minus resolution period over resolution period times fees. So basically, if the resolution time is smaller than the resolution period, smaller than or equal than the resolution period, then the opportunity cost would be 0. So we expected the payment to resolve in the resolution period. It did, so we don't have any opportunity cost. But if it takes the payments longer, if the resolution time is longer than resolution period, then for each resolution period that it's longer, it's basically robbing us of the fees that we could earn. So the opportunity cost is basically this times fees. So this is the opportunity cost, and then let me see. Here is the logic. Here's the logic that we use to update the reputation for our peers. So basically, if an HTLC comes through that the endorsed field was set to 1, so it was an endorsed payment, and then we basically updated the reputation of the neighbor as this formula suggests, this one. So we say effective fees are fees minus the opportunity cost. So if you're paying me some amount of fees and you're not costing me any opportunity cost, so if the payment results in under the resolution period, in less than the resolution period, then I'm just gonna add the fees to your reputation. But if there is an opportunity cost, if the payment took longer than I expected it, then I would either set the effective fees to 0 or even a negative number. For example, if this opportunity cost, if this formula results to 1, basically if this resolution time is even a little bit longer than a resolution period, this would be 1, and so we're gonna set the opportunity cost to fees, and then this would be 0, right? Or if the resolution time is twice as long as the resolution period or 3 times as long as the resolution period, then this could be like 2 or 3 or something like that. And then when we multiply this by fee, the opportunity cost would be like, could be twice as much as fees or 3 times as much as fees. So these effective fees can be negative. So in this case, we can like subtract something from the reputation of a neighbor because the payment was endorsed and it didn't result as expected. So we can either like add something here or subtract something. Otherwise, if the payment is not endorsed, we don't want to subtract anything from the reputation of the peer, right? We don't want to like negatively impact the reputation because the payment was not endorsed. We did know that this payment is not trusted. So if it successfully went through, like it wasn't endorsed payment, but it successfully went through, then we calculate the effective fees as fees times half, like half the fees. Why half the fees? Because if we give the complete fees here, then there is no incentive for nodes to set the endorse field to 1 and risk their reputation fee, and they risk their reputation. Because this is fees, this is just as much as this effective fees like up here could be, right? So if this was just fees, then nodes would always send the endorsed fee to 0 and like get the upside without tolerating the risk, right? So we should have this half the fees here, so nodes have an incentive to set the endorsed fee for 1, because if they set the endorsed fee for 1 and the payment goes through as expected, they can earn as much reputation as the fees, not half the fees. So they would be incentivized to fill the to set the endorsed fee to 1 if they actually trust the payment. And otherwise, like this is the part that the payment wasn't endorsed and it didn't resolve as expected, so we just set the effective fees to 0 because we don't want to negatively affect the reputation of the peer, but we don't want to add anything to it either. So that's the thing. So okay, in the next step, we want to calculate the risk that we are tolerating for the in-flight HTLCs. So basically in this part, we want to prevent a peer that has a good reputation with us to be able to abuse that reputation with like a burst of in-flight HTLCs. So we basically calculate the risk for each in-flight HTLC and subtract that from the reputation of the neighbor. So if a neighbor has a reputation with us, it won't be able to send many in-flight HTLCs at the same time and abuse that reputation, because for each in-flight HTLC we are subtracting the risk of that HTLC not resolving in time from the reputation of the neighbor. So this prevents that. And then for the last part, this part is basically for the changes in the network. So we have two sliding windows, the routing window and the reputation window. And how this works is that we calculate the reputation of basically the reputation window is longer than the routing window. It's like the recommended default is like 10 times the routing window. What we do here is that we calculate the reputation of the peer during this reputation window, and we calculate the amount of, how can I say this? The amount that the peer is using from that reputation over the routing window, which is a smaller window. So we say if a peer has like 10 reputation points with me during the past like 10 hours, it can use only those 10 reputation points in the past hour. Like it shouldn't be able to use more than that. So these are the formulas for that. So basically a peer is classified as having good local reputation if and only if the reputation revenue, which is calculated during this longer window, is bigger or smaller than the routing revenue, which is calculated in the smaller routing window. Otherwise, the peer's reputation is classified as neutral. So these are the three parts that create the recommended reputation system. The first part was how to update the reputation for each peer. The second part was handling in-flight HTLCs, and the third part was introducing the rolling windows and how to basically how to adapt to the changes in the network. And the rationale is basically we want to prevent jamming attack, and we want to be able to let the payments that are trusted by the network to go through for them. We want to have more availability for them. So yeah, this is the whole proposal, and there has been a lot of discussions. As you can see, 56 discussions here. There has been a lot of discussions, but many of them are about the second part of the proposal, about the reputation method that was recommended. But that's something that it's just a recommendation, so it's not actually the core of the Lightning. And I agree with the latest comment here from Thomas that it says we shouldn't talk that much about the recommended system because that's not a core of the Lightning Network. But these two questions are the questions that we should ask ourselves, how much what would be the granularity of that reputation, that endorsed field, do we want it to just be a Boolean, endorsed and not endorsed, or do we want it to have a range and have more than one bit of information? And the first one is this in general a good idea to pass this information along? So these are the two questions that we should ask ourselves. I don't think people have problems with the infrastructure that is built, passing around an endorsed field. Many of the questions were about this recommended method for reputation, but that's just optional. People can change it as they want. So yeah, that's it.